Hello guys, so let us do statistics. So today class will be about statistics, and hopefully we shall do a lot. So hopefully we shall do a lot. I shall be brief. I will try and be brief as much as possible. So for statistics today we shall talk about the measure of central tendency. Measure of central tendency. Once we finish our measure of central tendency, we can try also to look at measure of dispersion as our next topic for statistics, and then we complete with the skewness, moments, and kurtosis. So with the skewness, moments, and kurtosis. So welcome to statistics class. So when we talk about measure of central tendency, now remember that it is very difficult. So remember, it is very difficult to understand mass data, or when we have a lot of data. So it is very hard to understand, and therefore the issue of central tendency comes in. Now, in order to get a concise and a complete picture of large data, it is essential to obtain figures which should represent the whole data. So remember, when it comes to large data, it is essential to obtain figures, and that figure should represent the whole data. And therefore, the issue of the central tendency comes in. Now, by the help of such figures that we are talking about, the data are compared and you can understand the data easily. So that data, or that figure that we derive, is what we call the measure of the central tendency. So remember, when you have mass data or large data, it is very hard to explain the data, or to get the concise and complete picture of the large data. And therefore, we need to come up with the figures. So those figures is what we mean by measure of the central tendency. So let us see. So it refers to a figure which represents the whole data. So when we talk about a figure which represents the whole data, is what we mean by the measure of the central tendency. Another name of a measure of central tendency is what we call average. So average is another name which we can use to replace measure of the central tendency, which it removes the necessary details of data and gives a concise picture of a huge data under investigation. Let us see, what are those figures? So those figures are, for example, arithmetic mean, median, mode, geometric mean, and harmonic mean. So those are the examples of figures that we are trying to use so as to come up with a concise and clear picture of our data. So when we talk about refers to a figure which represents the whole data, those figures is what we call them the type of the averages. Now let us see the qualities of those figures or those averages. So what are some of the qualities? Number one, as you can see there, it should be rigidly defined, meaning you cannot easily change the final outcome, or you cannot define it differently. So when we talk about rigidly defined, it means that something is set with a very strict and precise limit that cannot be easily changed or interpreted. You cannot interpret it differently. Number two, it should be based on our value, that is normal. So when we talk about arithmetic, when you compute, for example, arithmetic mean, we need to use all the value inside. Next, it should be easily to calculate and easy to understand, and then it should be least affected by the fluctuation of sampling. So the sample, if the sample are fluctuating, then it should not affect the figure or the averages or the central tendency that much. Then it is capable for further investigation, i.e. you can do more statistical investigation on it. For example, apart from doing mean, median, mode, you can do like standard error, you can do the ANOVA, that's the analysis of variance. You can do all other measures, even including the econometrics measures that you can find. Another one, it should be least affected by extreme values. So it should be least affected by extreme values. Let us see some of the other characteristics that you need to know. You can also add, it should have sampling stability. So another characteristics, it should have sampling stability. So a good measure, or an ideal, or a good or an ideal average should have a sampling which is stable. And then the definition of an ideal average should be in form of a mathematical formula. So ideal average should be in form of mathematical formula. Formulae. So those are some of the item that you need to know when you talk about measure of the central tendency. Maybe what I can add, measure of the central tendency is also called central value. So you can also say it is also called central value. So you can also say it is also called central value. And when we talk about central value, we are talking about measure of location. You can also use the word measure of location. And then we have 5 of them. So we have several measure of central value. We have 5 of them. We have the AM, that is the arithmetic mean, median, mode, geometric mean, and we have the harmonic mean. So those are the 5 items that you need to know. And then among the mean, median, and the mode are called sample average, and the 2 average, geometric mean, and harmonic mean are called specific average. So the first 3. So we have the first 3. This one, and then you have this one called the specific average, and then the other one is called simple average. So in an exam, if they tell you to state examples or type of simple average, then you have the 3: arithmetic mean, median, and the mode. Then the specific average, you have the geometric and harmonic mean. So let's start with the first one. That is the arithmetic mean. So let us start with the arithmetic mean. Now arithmetic mean is also called mean. Some people call them the simple average, and other people call them the mean of the variable. The mean of the variable is the same thing. Now refers to the sum of the observation divided by the number of observation. So when you take all the observation, for example, x1 plus x2 plus x3 up to xn, these are the values of our observation. When we divide it with the number of observation, which is 1, 2, 3 up to n, that becomes our number of observation. So when you take the sum of the observation, we divide it with the number of observation, we shall get our mean. And that mean is what we call the arithmetic mean or the simple mean. Some people call them the simple average. Now, we have the formula here. x1 plus x2 plus x3 up to xn is the same as saying the summation of the x's. Then we divide it with the number of observation as normal. This formula is formula for ungrouped data. Ungrouped data is we also call them the raw data. So raw data means it's ungrouped data, the data which has not been filtered. So we call them the raw data. Let us say an example of a raw data, and we are going to use the direct method. So we have 2 methods. We have the shortcut method and we have the direct method. For purpose of illustration, or the purpose of this class, we are only, for the purpose of course outline, we are only interested with the direct method. We are going to use the direct method. Direct method. But if you have time, you can go and study shortcut method. So, but for me, I'm going to use the direct method, which is our formula above. So, mean will be equal to the summation of summation of our values, which is 2 plus 4 plus 6 plus 8 plus 10. We divide it with the number of observation. What's the number of observation? 1, 2, 3, 4, and 5. And 5. So this is what we call the direct method. So 2 plus 4 plus 6 plus 8 plus 10 divided by 5. So our mean is 6. Our mean is 6. So as I said, I'm not going to use the direct method. I'm not going to use the direct method. We can do another example. We can try another example. So let me write the example. Another example. Calculate the mean of, so we have 75, 55, 48, 72, and 60. Solution. So our x bar will be equal to 75 plus 55 plus 48 plus 72 plus 60. Then we divide with the number of observation. So 1, 2, 3, 4, 5. Divide by 5. We shall get your answer. So what will be the answer? So let us see. 75 plus 55 plus 48 plus 72 plus 60. This is 310 divided by 5. So 310 divided by 5 is 62. So the mean is 62. As you can see, we have used all the data. We have used all the data. Let's go to the next method. And the next method is the method for grouped data. So let's go to grouped data. Grouped data. Grouped data. Let's go to grouped data. Grouped data. So let us see the grouped data. Now, when we talk about the grouped data, so grouped data is different from ungrouped. So we say that ungrouped data is data which has not been classified, meaning we do not have classes of information. It means that it's a raw data, meaning that there is no filtering of that data. When we talk about ungrouped data, there is no classification of that data. So the data is raw. But when we talk about the group data means data that has been organized into categories. So when we talk about group data, refers to the data which has been organized into categories or into classes instead of listing each individual value separately. For example, when we were talking about the ungrouped data, we just list some numbers. We do not know they belong to which account, or we do not know. So it's just a raw data. But when you talk about grouped data, it's a data which has been organized into categories or into various classes. Now let's do this question together. Now, as I said, I'm going to, all my examples, I'll be using the direct method. So all my examples for class purpose, I'll be using the direct method. But in case you want to know more, you can reach out to me on this number. Now, remember we are going to use the group data. This is a good example for group data where we have the marks And each marks, we know that 8 students scores 84, 18 students scores 63, so it is grouped according to marks and the number of students. So fx, so we need a table where we shall have our marks, which is x, then number of students, which is our frequency, number of student, which in this case is our f. Then we need fx. We need fx. So let us see. So we have 64, 63, 62, 61, 60, and 59. I think that one is fine. Then you have 8, 18, we have 12, we have 9, 7, and 6. So let us find fx. Let us find fx. So 64 times 8. 64 times 8, how much? 512. 63 times 18. 1134. 62 times 12. We have 744. 61 times 9. 549. 60 times 7. 420. Then 59 times 6. We have 354. Then we find the total. So how much will be the total? Now we will need two totals. We need the total of f and fx. So we need the total of f, which is n. This is summation of fx. So 8 plus 18 plus 12 plus 9 plus 7 plus 6. That is 60. Then you have 512, 1134, 744, 549, 420, 354. That is 713. That is 713. That's 713. Now, for us to get our mean will be equal to the summation of fx, which is that 713. We divide it with number of n. Our n is summation of the frequency, 60. So divided by 60, which I get 61.88. 61.88. 61.88. 61.88. That one is correct. That one being said, I think we can progress to another question. Let's do for continuous. So let's see, in case we have continuous data, grouped but continuous. Let's look for group but continuous data. Grouped but continuous data. How do we do it? So grouped but continuous data. So grouped but continuous data. So let us do it. So another illustration. So I hope you are done with this example in our board. So I want to wrap it so that we can do now where we have continuous data. Remember, this one is not a continuous data. 64, 63, 62 is not a continuous. These are just numbers. Let us see an example where we have continuous data. Continuous data. So let's see this example. Now remember the previous example, we did a district series. The series is for this one, for example, you have marks and number of students, where we have 62 students, 51 students, 40 maybe 3 students, 30 students, 8 students. This is an example. This is an example of a district data, and we did an example in our previous example that we did. Now, for continuous data, these are good examples of continuous data. When you have 0 to 20, 20 to 40, 40 to 60, you can compare this one and this one, 60, 50, 40, 30. This one is a district data, that one is a continuous. Now, what we do with this example, the first thing you do is we find our midpoint. So we need to find our midpoint. So that's the solution. So I'll do the solution in this side. So allow me to come up with a solution from this side. Solution. So we have max. Then we need to find the midpoint. And then number of students, that is the frequency. So midpoint is our x. Remember, midpoint is our x. Then number of students is our frequency. Number of students is our x. Then now we can find our fx. So we have 0 to 20, 20 to 40, 40 to 60, we have 60 to 80, then 80 to 100. So we need to find the midpoint. So we need to find the midpoint. Let us do it together. So the midpoint, I'm going to show you how to get the midpoint. So let us see the midpoint. So the midpoint will be equal to 0 plus 20. The first one is 0 plus 20 divided by 2, which is 10. The second one is 20 plus 40. So the upper plus the lower limit. So the lower limit plus the upper limit divided by 2, which is 30. Then 40 plus 60 divided by 2, which is 50. Then 60 plus 80. 60 plus 80, so the upper divided by the lower limit, 70. Then 80 plus 80 lower limit plus the upper limit plus 100 divided by 2, which is 90. Then you have 5. We have it here. Number of students 5, 7, 13, 8. Then 7. Then you find fx. So fx times this is supposed to be f. So fx. So this one is 50. This one is to 10. We have 50 times 13, 650. Then 70 times 8, 560. Then 90 times 7, 630. Then you need to find the total. So the first total here is f, summation of f, which is n. Shall call it n. Summation of the frequency, 5 plus 7 plus 13 plus 8 plus 7, 40. Then this one is summation of fx, 50 plus 210, 50 plus 210 plus 650 plus 560 plus 630. So this one is 2100. So meaning our mean will be equal to 2100 divided by 40, which is 52.5. So that is our, actually that's our arithmetic mean. Sorry. That is our arithmetic mean, 52.5. Arithmetic mean is 52.5. This is a direct method. So remember that one is direct method. As I said, I'm going to use the direct method. Direct method. The other method which I'm not using is called the shortcut method, which you can, it is not necessary, but you can run shortcut method. But as I have said, I will concentrate with the direct method. I'm going to concentrate with the direct method. Let's see the advantages and the disadvantages of the arithmetic mean. Number one, it is rigidly defined. It is rigidly defined, meaning you cannot easily change the interpretation. So the interpretation is fixed. So it is rigidly defined. Number one. And you remember one of the ideal of a good measure, an ideal or a good attributes of a good average is rigidly defined from our previous notes. It's the same thing. Number two, you can easily understand and calculate. You can easily calculate it. Number three, if the number of item is sufficiently large, another advantage, if the number of the item is sufficiently large, it is more accurate and reliable. So if the number of item is large, if number of item is large, if number of item is large, if the number of item is large, then it is more accurate and more reliable. It is more accurate and reliable. It's more accurate and reliable. So if the number of items is sufficiently large, supposed to be sufficiently large. Sufficiently. So if the number of items is sufficiently large, then it means that it will give a more accurate and reliable data. It is calculated. It is a calculated value. It is not based on its position or in its series. So another advantage is that it is a calculated value. So that's an advantage. It is a calculated value. For example, this value. This one is a calculated value. So it's a calculated value, and it is not based on positions. It is not based on its position. It is not based on its position in the series. And then it is possible to calculate the mean if some values misses. So it is possible to calculate the mean if some value misses. That's another advantage. So another advantage is that you can easily calculate the mean even if some figures are missing. Even if some figures are missing. Another advantage is that it is least affected by the fluctuation of sample or sampling. So it is least affected. It is least affected by fluctuation of sampling. And then the last advantage, it provides a good basis for comparison. It provides good basis for comparison. So it provides a good basis for comparison. It provides a good basis for comparison. Other advantages is the characteristics, as we said in our previous, in this session as we started. So another advantages that we can add is the ideal or the good attributes of the measure of the central tendency. Disadvantages of this method. Number one, it cannot be calculated in an open-ended classes. It cannot be calculated in an open-ended classes. That's one disadvantage. It cannot be calculated. So disadvantage number one, it cannot be calculated in an open-ended classes. Open-ended classes. Open-ended classes. Number two, it is affected by extreme value. It is affected by extreme values. Extreme values. It is affected by extreme. For example, you have one number is 20, another number is 1000. When we get the average of these two numbers, it can give incorrect average. So when you have extreme values inside, and then it cannot be in the study. It cannot be in the study of qualitative phenomena. So it cannot be used in the study of qualitative phenomena. So it cannot be used. It cannot be used. It cannot be used in study of qualitative phenomena. So it cannot be used in the study of qualitative phenomena, and also it cannot be obtained by inspection. It cannot. Another disadvantage, it cannot be obtained by phenomena. sorry, it cannot be obtained by observation. It cannot be, sorry, by inspection. It cannot be obtained by inspection, or not located. It cannot also be located by frequency graph. By frequency graph. So it cannot be located by frequency graph. So you cannot use the graph, the frequency graph, to locate it. So those are some of the advantages and disadvantages that we can find when we talk about the arithmetic mean. So those are some of the advantages and disadvantages that we can talk when we talk about arithmetic mean. Let's see if you have we have been able to give all the disadvantages. Number one, we have said it is affected by the extreme values. That is correct. So one disadvantage is affected by the extreme values. Number two, it may be a figure which does not exist in a series. It can be a figure. It may give a figure which does not exist in the series. It may give a figure. It may give a figure. It may give a figure which does not exist. Which does not exist in the series. In the series. So it might give a figure which might not exist in the series. It might give a figure which might not exist in the series. And then it cannot be used in qualitative data, as I said. It cannot be used in qualitative data or qualitative phenomena. It cannot be used in qualitative data or qualitative phenomena. Now, without wasting time, let us go to the weighted average. Let us go to the weighted average, weighted arithmetic mean, weighted arithmetic mean, weighted arithmetic mean. So weighted arithmetic mean. So let us continue. So when we talk about the weighted average, this is the formula. We take the weight, we multiply with the number of item up to the nth weight and the number of item. Then it will divide with the total weight. Now let us see some of the useful circumstances when we use the weighted average. So it is useful in the following circumstances. Number one, when various items of a series are not of equal importance. So it is used when the various items in a series, they are not of an equal importance. So we can use this method. Number two, when the ratios, percentage, and the rates are being averaged. So when you are averaging those ratios, percentage, and the rates, this method, weighted average, is more applicable. And then when it is required to calculate the averages of a series from the average of its component part, this method is also useful. So it is useful when we are calculating the average of a series from the averages of its component parts. And then when the proportion of the values of the item changes, or when the proportion of their frequencies also changes. So it becomes also useful. And then when the classes of the same group, when the classes of the same group shows a considerable variation in frequencies. Shows a considerable variation in frequencies. So this is an example. Let's see this example of a question that we want to do. So the following data indicate an increase in the cost of living for a working class over a period of 3 years, and the weighted assigned to the various groups. So you have various group: food, rent, clothing, fuel, and the other item. Then you have the percentage increase in the weight. So let us see how we compute this one. So let us see how we compute that one. So we need to come up with our weight, our x, our weight, which is our w, and then we need our xw. So we start with the food, which is 29. Sorry, and then we have a group. Sorry, group which we have food, which is 29. This one is 7.5 our weight. Then we multiply. So we need to multiply. So 29 times 7.5. That is 217.5. Then we have rent, which is 54 and 2, which is 108. 108. Then we have clothing. Clothing 97.4. 1.5. So 97.4 times 1.5. This is 146.1. Then 75, that is fuel. 75 and 1, which is 75. Then we have others. Others, 75 times 0.5. That's 7.5. So we can find the total. So the total here is summation of weight, which is 7.5 plus 2 plus 1.5 plus 1 plus 0.5, which is 12.5. Then you have summation of xw, which is 217.5, 108, 146.1, 75 plus 37.5, which is 584.1. 584.1. Now we can do now what? Now we can do the mean, arithmetic mean, or the weighted arithmetic mean. Weighted arithmetic mean to be equal to the summation of xw over summation of w, which is 584.1 divided by 12.5. So divided by 12.5, that is 46.728. So that one marks the end of arithmetic mean for this class. Now, advantages and disadvantages of weighted average, of weighted arithmetic mean is the same as the advantages of arithmetic mean. So you need to know NB, advantages and disadvantages of arithmetic mean is same as that of weighted arithmetic mean. Weighted arithmetic mean. Weighted arithmetic mean. Weighted arithmetic mean. Now we can proceed to the next one. The next item that we are going to proceed is median. So let's talk about median. Median. Let us talk about median as our next item. So let's try these two examples. Now we have said that we'll talk about median. So median refers to the value of the value of the middle item of a series when those items are arranged either on ascending or in a descending order. So that is one scenario you need to know. So you need to arrange the number either into a descending or descending order. Now this is the formula. Now this formula is purposely for ungrouped data. So this formula given here is purposely for ungrouped data. ungrouped data. So we are going to do, we are going to calculate median when we have ungrouped data. Now, if the number of the values are odd, the median is the middle value. So the median is the middle value. If the number of the values are even, the median is the mean of the two values. The median is the mean of the two values. Now, the first thing now, let us arrange this. So let's do example 1. So solution for example 1. So the first example 1. So the first example is for odd value. The reason why, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 is an odd value. So let's see how we compute. So we arrange first in ascending order. Arrange in ascending order. So we arrange in ascending order. So we start with 8, followed by 10, followed by 18, followed by 20, followed by 25, followed by 25, followed by 27, followed by 27, then followed by 30, then followed by 42, then 53. Let's count to see if it's 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Correct. Then our median, remember the formula for the median is equals to n plus 1 over 2 nth item. So let us compute. So our n is 9. So remember our n is 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it will be equal to 9 plus 1 divided by 2, which is 9 plus 1 is 10 divided by 2, 5. So fifth item. So our mean is the fifth item. So let us see the fifth item here. The first item, second, third, fourth, fifth. So our fifth item is 25. So 25 is our median. So you can come and say median is 25. That is the fifth item. Now let's go to example 2, where we have odd. So example 2, find the median of the following item. Now before we do, let us arrange in ascending. Let's arrange in ascending. So the first item here, if we arrange ascending, we have 2, followed by 5, then 8, then 12, no, not 12, then 10, then 12. So 10, then 12, then 20, then 18, then 18, then 22, then 30, then 22, then 30. So let's count to see if they are even number. So 1, 2, 3, 4, 5, 6, 7, 8. 8 is an even number. That is correct. Now let us now find the middle figure value. So eliminate 2 with this item. That is the first one. The second one, 5 and 22. Next, 8 and 18. Then we are remaining with the 2 values. Then we said, if the numbers of the values are even, the median is the mean of the 2 values, the 2 remaining values. So the mean is, the median will be the mean of the 2 values. So if it is an even number, the median will be the mean of the 2 value remaining. So which 2 value? 10 plus 12 divided by 2. That one becomes our median. So 10 plus 12 divided by 2, that is 11. Then we say median is 11. So that is our median. Our median is 11. Or you can use the formula. We can also use the formula. We can use the formula and say, we can say use the formula. Let us see if you use the formula. So remember, it is n plus 1 over 2 nth time, nth item, nth item. So we say it is what? Number of item 1, 2, 3, 4, 5, 6, 7, 8. It is 8 plus 1 divided by 2, which will give us 9. 9 divided by 2, which is 4.5. Remember, with nth item. Remember, we cannot find the 4.5 value. We say that we find the fourth value or fifth value, but we cannot find a number with a decimal. So how do we do it? Now we shall say our median will be equal to the fourth item plus a half. Remember, 0.5 is a half. So remember, 0.5 is a half. A half of what? A half of fourth minus fourth, so not fourth, the fifth. Fifth is the number which is above 4.5. Then we less the number which is below 4.5. Which number is below 4.5 is the fourth item. So we take the fifth item. So 4.5, when we talk about 4.5, the number above 4.5 is fifth. The number below is fourth. So we are supposed to take the fifth item, we less the fourth item. So let us try and see if we shall get the same answer. So our mid, let's see the fourth item. 1, 2, 3, 4. Our fourth item is 10 plus a half. The fifth item, 4. 1, 2, 3, 4, 5, 12 minus 10. You need to get the same answer, which is 11. So let us see. 10 plus a half. 12 minus 10 is 2. So it will be equal to 10 plus a half times a half is 1. The same answer as 11. So 11 becomes your median. 11 becomes your median. 11 becomes your median. 11 becomes your median. So that is all about ungrouped data or the raw data. So these are ungrouped or the raw data. So other people call them the raw data. So ungrouped or the raw data. So let's go to ungrouped to grouped data. Let's go to grouped data. Grouped data. Okay. Let's see this grouped data. So for grouped data, so in a grouped data, in a group distribution, the values are associated with the frequency. So we talk about the grouped data, the value is always associated with the frequency, as we have seen in our previous subtopic. Now, grouping can be in form of, number one, it can be in form of discrete frequency distribution, or it can be continuous. So remember discrete, this is a good example for a discrete. Continuous, where we have 0 to 20, 20 to 30, 30 to 40, that is a continuous. But discrete is where we have the value of x and we have the corresponding frequencies. Now, whatever the type, cumulative frequency must be calculated. So, whatever the type of distribution we are talking about, either discrete or continuous, cumulative frequency must be calculated. Now, what is cumulative frequency? Now, cumulative frequency is the sum of the frequencies. So, cumulative frequency is the sum of the frequencies of classes and the frequencies of the previous classes, i.e., adding the frequencies successively so that the last cumulative frequency will be the total number of the item. That is correct. Now, for the discrete series, step number 1, when computing median, we need to find the cumulative frequency. Then we find the n plus 1 divided by 2 and the item. Then we see the frequency that is greater than this item. Then we find the corresponding value of x, which will be our median. So let us see with this example. So step number 1, we are supposed to calculate the cumulative frequency. So we have x and we have frequency. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I hope up to that point it is visible. Then we need to find cumulative frequency. Cumulative frequency. I hope up to that point it is visible. So we have 1, 3, 5, 6, 10, 13, 9, 5, 3, 2, 2, and 1. So let's find the cumulative frequency. The first one, cumulative frequency will be 1. So 1 plus 3 is 4. 4 plus 5 is 9. 9 plus 6 is 15. 15 plus 10 is 25. 25 plus this one is 38. 38 plus 0, that is 47. 47 plus 5, that is 50. 52. 52, that is 55. 57. 7 plus 2, that is 59. 59 plus 1, that is 60. Now we need to find the nth, n plus 1 over 2, and the nth item. So that is the cumulative frequency. So how do we get the cumulative frequency? Which we take 1. For the first item, the 1 will be the 1 will be the same as frequency, and the cumulative frequency will be the same. But for the second item, it will be 1 plus 3, which is 4. 4 plus 5 is 9. 9 plus 6 is 15. 15 plus 10 is 25. 25 plus 13 is 38. Plus 9, 47. Plus 5, 52. Plus 3, 55. Plus 2, 57. Plus 2, 59. Plus 1, 60. So 60 is our n. So 60 is our n. Plus 1 divided by 2. So what will be the figure? So the figure will be equal to 60 plus 1 divided by 2. That is 30.5. 30.5. So step number 1, as we said, we find the cumulative frequency. Our cumulative frequency, we have it here, and the total is 60. That is our n. Then we find n plus 1 over 2. We have it here, 30.5. Then any value which is greater than 30.5. So which one? Where does it lies? So where the 30.5 lies? It lies between 25 and 38. So it is within this point. So meaning our median is 6. So the number below is 6. So above 25. So the number above 25 is 30.2. Not, yes, correct. 30.5. So it is, the median is 6. So the median in that case is 6. So that is for discrete. Let us look for continuous. Let us see for the continuous data. Let us see for the continuous data. Continuous data. Continuous data. So let us see the illustration below for continuous data. Now for continuous data, as you can see in the board, is that the following step can be used. Number 1, we find the cumulative frequency. Number 2, we find the value of n over 2. So n over 2 is the n over 2 nth value or the nth item. Then number 3, we find the cumulative frequency that is greater than n over 2. Number 4, we find the corresponding class interval, which is called the median. Then we apply the formula as follows. So median is equals to L plus n over 2 minus m over f. Then we multiply by c, where L is the lower class limit, m is the cumulative frequency of the preceding median, c is the width of the median class, f is the frequency of the median class, and then n is the total frequency. So let us do it together. Let us do that equation together. I'm going to do it here. Solution. Solution. So the solution will be done from that point, and I hope it will be visible. So what we do first, we come up with our max, which is x, then our frequency, which is the students, f is our students, so 0 to 10, 10 to 20, 20 to 30, then 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80. So that is all. Then we also input our frequency, which is 2, 18, 30. We have 2, 18, 30, 45, 35, 20, 6 and 3. Then we find the cumulative frequency. We said for median, no matter what, we need to find the cumulative frequency. The first frequency is 2, meaning the cumulative frequency is 2, plus 2, that is 20. So 18 plus 2, that is 20. 20 plus that is 50. This one is 95. So 95 plus 35, that is 130. 150, 156, 159. So 159 is our frequency. That one is correct. So once we have the frequency, we can find n over 2. We can find n over 2. So let us find n over 2, which is 159 divided by 2, which is 159 divided by 2. So n over 2, nth item, which is 159 divided by 2. How much is that? So 159 divided by 2, 79.5. That is 79.5. Now we can now input our formula. Our formula is for median is, now first let's locate 79.5. Where does it lie? It lies in this point. So 79.5, it lies between this point. So between this line. So between 50 to 95. So we can say it is 79.5. That is 79.5. Let's locate now the lower class limit, our L. So our L, so remember our formula, we are using this formula. So remember we are using this formula, let me write it here. L plus n over 2 minus m over f, then multiply by c. Let us see mid. We say it's a lower class limit. It is a lower class limit. So L is the lower class limit. Let me check again. Actually, it's the lower class limit. So let us locate it. Our class limit is, so 30 and 40. So 40 is the upper class limit. That is the lower class limit. So it is 30 plus n over 2. So n over 2 is 79. We have it here. 79.5 minus our m. Our m is the cumulative frequency of the preceding median of the proceeding median. Proceeding median is the one which is below, which is above. So before ilikuwa inafuatia nyuma yake. So our cumulative frequency is 95. Which one is below? The proceeding is the one which is nyuma yake, 50. So minus 50 over the frequency of this item. So the frequency it is which is just there, 45. Then you need to multiply it with the cumulative class limit, which is 40 minus 30, which is 10. So 40 minus 30, that is 10. This one, 40 minus 30, that is the class C. That is the width. So let us do it. So 79.5 minus 50. So MD is equal to 30 plus, so 79 minus 50, 79.5 minus 50 is 29.5. 29.5 over 45. Then what you get to multiply by 10. So MD, so 29.5 divided by 45. So 30 plus 0.655 times 10. Then our MD will be equal to times 10 plus 30. That is 6.55. So that's our median. That 6.55 is our median. That is 6.55 is our median. That is 6.55 is our median. So what you need to remember is you need to first calculate the cumulative frequency. Calculate the cumulative frequency as we have done. Calculate cumulative frequency. Once you calculate cumulative frequency, you find n over 2, that is here. So n is the total, the last item. Or you add this plus 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 this will give you a total of 159. This 159 is what we call the n value. So 159 divided by 2, get n over 2. Then I'll use the formula. So the lower limit, so you locate where the 72 lies. It lies between 50 and 95. So you pick the maximum, which is 95. So 95. Then you locate the lower limit. The lower limit for this figure, it is either 30 or 40. 40 is the upper limit. That is the lower limit. So that is the lower limit. You pick that. So 79.5 n over 2 minus 50. 50 is the proceeding. Proceeding is the one above. Minus 50 divided by 45 times 10. So then you shall get 36.55 as our median. That one marks the end of class of our median. The next class we are supposed to talk about is the mode. Mode. I think we shall continue from the mode in our next class. We shall continue from the mode in our next class.